Hello everyone, this is Pamper Chew. Today I got the cover off of this used battery backup made by OnGuard PC. I don't know that name, but it looks like it was a part of a CLARY. I think that's what it says. Yeah, CLARY. They made server stuff, I believe. Other scientific equipment. And it's one of the nicest front panels I've ever seen, even including the modern ones. This one has a load meter, a battery, alarm, INV, I forget what that is. Oh, inverter. So if the power's out, that'll light up as being on. AC light. And this is how they arranged the batteries inside. I'm not sure if it was because of the technology they had, only having these smaller packs. I'm sure they had the larger packs, but I've never seen one arranged in this way. It looks like that would be 36 volts. All right, Duncan. So this is a 36 volt battery backup. You have 3 12 volts there and 3 down here. Yeah. From 1991, was it? Where'd it go? 1991, January, 92. So that would be 25-year-old.
And it still works.
No, the batteries are dried. It turns on and works, but no capacity. You unplug it and it just goes. But it has a really neat styling of the early '80s computers.
So creative.
It is.
$25
$25 with the batteries, which will get $30 in scrap.
Wow.
Yeah. And so you can replace these batteries pretty cheap. They're about $12 each. And if you've been looking for a battery backup that's about this size, they're around $500 to $1,000. So it's a really good deal. That one looks like it might have been leaking there. Wow, that is
Drink some water.
That is very impressive. So this is just like a big audio amplifier, and it makes a sine wave. And when the inverter's running, it's generating the 60 cycles instead of the generator at the power company. Most battery backups make a square wave. This one should make a sine wave, or a close enough sine wave. I forget what they call it. It's a good enough sine wave. I don't see the big power transformer in this one. Maybe it just doesn't need one. There's a couple small ones there. Actual relays. Let's see, 30 amp fuse. Wow. Oh, that must be for the battery packs. Going to the utility interrupt, which you would have hooked up to a control panel. They'd all be connected together, so you can interrupt them all, or in order, whatever you wanted to do for testing. You design it using that as the controls. This one does have constant cooling. It's the first time I've seen one where the fans are always running. Those are Mitsubishi fans. Date code on that. I don't see one. It has a capacity of 1.25 kiloamp volts, which is a pretty decent size. This is the cover that's been taken off already. It's nice white color with some ventilation, and it's square and made of metal. Like some of the ones today I've seen now are black plastic and shaped funny, unable to stack easily. I'm sure they do that on purpose for heating and cooling issues. But there's the sticker for the power on off switch. This is the warning label to it. This is the reason why I bought this one of the three, is because it had this sticker on it, where the other two had a slightly less old looking version. I don't know if this was the first release or not, but this was sticker. Reminded me of stuff you see down in old mine shafts, the warning. And it was held on by 6 screws on each side, and then 2 screws on the top. So it's built very well. I think I just need to turn this on here. Get it going? $673, 26, 260 watts going into this thing. So that means around around 67 of that is being lost in the UPS right now. Power factor 0.64, and it's on a tungsten lamp, so nothing. Oh, there it goes. 2.3 volts there. Yeah, these are cooked. So, of course, remove the pack from the device. And if you're really worried about it, split the packs up like this. I guess I should show you in case someone doesn't know. Okay, and then just remember how it was wired up, and if it was 12 volt, 24 volt, how many were in series, how many parallel, that kind of thing. You don't have to remember all this. It's a pretty easy circuit. But if you do need to write it down, just mark it on the metal part of the battery backup with a number or a positive, negative, whatever. So blue coming in from here, and that was on ground. And I can point to it. And where's the other color? So you just make a little drawing. And then that way, if you forget or don't know how they're set up, just follow the picture. You can tell they're really light. Really light. Date code. What do we have? That say December 16th, 1991. Almost as old as me. And they're only a little bit leaky up there on that one. Oh, what is that? That's not a normal leak. Oh, wow. What do we got there? Yeah. Something arc out, or that's probably dried lead powder and flakes. And you can see the dried up stuff that was in there. And it's all dried up. And I think that black stuff was part of the lead plates. It's turned to dust. Oxidation of It's blown away. Yep. And the white stuff was the glass, the fiberglass. Or is the fiberglass. See, that one cracked. They're pretty strong. All the parts to go with it. See, that was definitely pressure that made it crack. This isn't even, not one bit. How strong that is? They're very strong. Whoops. I was trying to push it. That's so cool. How'd you get all the cuts to look correct?
I don't know.
Is it just from the same tree?
From the same.
Well, like this one has no knots in it.
No, some have knots. There's plenty of knots.
Cedar?
Yeah, those are good.
Oh, cool.
Yeah. Yep, cedar. Let's think of that. Oh, my knees hurt. Oh my gosh. Knees hurt. Oh, knees.
Oh. Wow, it is. Big time. Okay. Alright, so I have it all put back together. It takes 6 of the 12-volt sealed lead acid batteries, these kind right here. And I just went on to Amazon and looked for the cheapest ones I could find. And I was able to get 6 of these for $90 with free shipping. And the new ones are 9 amp hour, so they will have a slightly longer capacity. I don't think they will be able to put out as much current, but it will have a longer backup time. This unit is equipped with an uninterruptible power supply. The date code on here is January 1992. And it's a model UPS 1-1.25K 1G. I'm guessing that means it is 1250 volt amps. There it is. Let's turn it on. I have it plugged into the kilowatt. So this is with no load, just the UPS running. Yeah, 67 watts. Let's turn something on. I have it plugged in to this right now. Let me find something else with a bigger load. Let's run it on a couple of these Bitcoin mining blades here. This totals 1500 watts, so I'll just plug in one of them. Ooh, nice arc. Let's see what happens if I put it all on here. All 1500 watts. I'm not sure my meter can handle it. eventually. I know my meter can't handle it, because I burnt myself last time I tried to do that. Overload. Okay. Alright, so at least it warns me. So yeah, what happened is it was pulling around 1100 watts. Two of those power supplies equal around 1000, so it was a little bit more than that with the light on. And that little red one lit up. All the green ones and the red one lit up. And beeped at me. The UPS that's under my desk and has been under my desk for the last year takes two of these. Alright, so for the last year, this has been my battery backup for the computer and both monitors. Now, I just got these in a previous video I haven't shown yet, and this is the first time I've hooked it up on my desk. This I've been using for about a month, and I've decided to use the second battery backup for the monitors today, just for testing. So here it is installed. I have it over on the right side of my workstation where I do all my editing and whatnot, and it's powering the amplifier, that plasma monitor, and I think that's it. Everything else in the room is being backed up by that one over there, including the microwave. It's all on battery now.